So in this video, we're going to go over limits involving what we call indeterminate forms. But for a moment, let's ignore that big term and just look at one example here. And that's the limit as x tends to -2 of x plus 2 divided by x cubed plus 8. So as x gets close to -2, the numerator gets close to 0. The denominator gets close to -2 cubed, which is -8, plus 8, which is 0. So this seems to be 0 over 0. Now we have an interpretation of like 0 over something, let's say y, is 0, right? And something over 0, or something is y, is going to be either plus or minus infinity, depending on whether y is positive. If it's positive, it's positive infinity. If it's negative, it's negative infinity. But what's the interpretation of 0 over 0? We know what 0 over something is 0, and something over 0 is infinity. So 0 over 0, is it 0 or infinity, or what is it? We don't know, and that's why we call it an indeterminate form. Because it's not possible to determine what it really means, what the value really is. And there are a few other indeterminate forms besides 0 over 0, and they are infinity over infinity, infinity minus infinity, 0 times infinity, 0 to the 0, 1 to the infinity, and infinity to the 0. So on top of 0 over 0. So these are all the types of indeterminate forms. And the ones you'll see most often in a first calculus course are going to be these three here boxed. So 0 over 0, infinity over infinity, and infinity minus infinity. Now when you've arrived at an indeterminate form, that doesn't necessarily mean the limit doesn't exist, but it does mean that you have more algebra to do. So let's get back to our example here. So we have the limit as x tends to -2 of x plus 2 over x cubed plus 8. Just going to go and rewrite it up here. Limit as x tends to -2 of x plus 2 divided by x cubed plus 8. And we saw that when we plugged in -2, we got an indeterminate form. But remember that x cubed plus 8 is of the form, this bears the form a cubed plus b cubed. And if you'll remember from your algebra classes, this is equivalent to a plus b times a squared plus ab plus b squared. Okay, so here a is x and b is 2. 2 cubed is 8. So a plus b, that would be x plus 2. A squared is x squared. AB is 2 times x. Oops, this should be, oh, this is wrong. Here, this is a cubed plus b cubed is a plus b times a squared minus ab plus b squared. This is actually x plus 2 times the a squared term is x squared minus a times b, so minus x times 2 or 2x, and then plus b squared, so plus 2 squared, which is 4. If you don't believe me, no, we can just expand this out. Squared minus 2x plus 4. X times x squared is x cubed. X cubed times negative 2x is negative 2x squared. X times positive 4 is positive 4x. Positive 2 times x squared is plus 2x squared. Positive 2 times negative 2x is negative 4x. 2 times 4 is 8. We have a minus 2x squared term and a plus 2x squared term. These terms can cancel. We have a plus 4x term and a minus 4x term. These terms can also cancel. We have x cubed minus 8. Or x cubed plus 8, sorry. Excuse my mistakes today. So, x cubed plus 8 can indeed be factored into x plus 2 times x squared minus 2x plus 4. So we'll see, and of course this is the limit as x tends to minus 2 of all of this stuff. And we'll see right away that x plus 2 in the numerator and x plus 2 in the denominator cancel. And you might be asking, do we have to worry about division by 0? It may seem like it because we're looking at x close to negative 2, but remember x doesn't have to be negative 2. We're only looking at x around negative 2, so we don't have to run into this negative 2 plus 2, because we're really looking at, say, negative 1.99999 or negative 2.00001, so we do not have a division by 0. So we are okay. This equals the limit as x tends to negative 2 of 1, this x plus 2 is gone, divided by x squared minus 2x plus 4. I'm going to continue that work down here. Well, I guess I'll draw an arrow like so. And that's the same thing. Remember that the limit of 1 over something is the same thing as 1 over the limit of that something. So the limit as x tends to 2 or negative 2 of x squared minus 2x plus 4. And what's this limit? Well, this is just negative 2 squared is positive 4. So we have minus 2 times x, so minus 2 times negative 2, and then plus 4. So we have negative, or 1 over 4 plus 4, and then plus another 4, which is 1/12. So you'll see here we had what seemed to be an indeterminate form, copied it over again here. We saw that this was factorable, we could cancel, and we were able to get rid of both zeros in the numerator and the denominator. And when simplified and applying some limit rules, we saw that this limit is 1/12. So the limit does actually exist in this case. I will look at another indeterminate form here. This time we're going to be looking at a limit as x tends to infinity. In particular, it will be the limit as x tends to infinity of 3x cubed minus 2x squared divided by x to the fourth plus x squared. So again, just looking at the numerator and denominator, as x gets to infinity, 3x cubed is going to approach infinity, right? And 2x squared is also going to approach infinity. Looking at the denominator, as x tends to infinity, x to the fourth is going to tend to infinity. And so is x squared, and they're added. But remember here that infinity minus infinity is an indeterminate form. You have a really large number minus another really large number, no telling how large these numbers are. So you can't say that this is 0. Okay. So you have an indeterminate form in the numerator. So we're going to somehow have to use algebra to get around this indeterminate form. And the trick we're going to employ here is going to be the same one that's used for a lot of rational expressions. So expressions in which you have both a polynomial in the numerator and one in the denominator. And we're going to multiply by 1, but a very special version of 1. And so we're going to be multiplying both numerator and denominator by 1 over x to the fourth. And really that's the same thing as dividing both numerator and denominator by x to the fourth. And the reason we're doing that, it's the highest power of any of the terms shown here. So we're going to be dividing both numerator and denominator, or multiplying by the reciprocal, multiplying both numerator and denominator by the reciprocal of x to the highest power shown here. And you'll see why this works and how this helps us circumvent this indeterminate form here. So that's the limit as x tends to infinity. 3x cubed divided by x to the fourth minus 2x squared divided by x to the fourth. So here we have x to the fourth over x to the fourth plus x squared over x to the fourth. So we simplify this a little bit further. You'll see this is equal to 3 over x. X to the third divided by x to the fourth is 3 divided by x. Again, we don't have to be worried about division by 0 because we're considering large values of x. So 2x squared over x to the fourth is 2 over x squared. That's because x squared over x to the fourth is 1 over x squared times 2 is 2 over x squared. X to the fourth over x to the fourth is 1. And x squared divided by x to the fourth is 1 over x squared. So let's look at this limit here. As x goes to infinity, 3 over x becomes a really small number and goes to 0. 2 over x squared, what happens to it as x gets bigger and bigger and approaches infinity? Well, x squared gets bigger and bigger, so 2 divided by x squared is going to have to get smaller and smaller, and closer to 0. Limit as x tends to infinity of 1 is just 1. 1's not going to change, it's not a function of x. 1 over x squared, what happens to it as x gets bigger and bigger? Well, x squared is going to get bigger and bigger, so 1 over x squared is going to get closer and closer to 0. So you have 0 minus 0 is 0, over 1 plus 0 is 0, is 1, is 0 over 1, which is 0. So here we multiplied both numerator and denominator by 1 over x to the highest power of any of the terms that was present here, and which was x to the fourth. Or you could say we divided both numerator and denominator by x to the fourth. And for a lot of functions in which a lot of limits involving functions that have a polynomial in the numerator and a polynomial in the denominator, this is the trick that you'll use to be able to skirt around this indeterminate form here and get a limit that is a determinate number, in this case 0. So between the previous example we looked at, which was limit as x tends to minus 2 of x squared, x plus 2 over x cubed plus 8 worked out here. In this example, you'll see a lot of solving limits, finding limits that initially appear to be indeterminate forms involves the use of tricky algebra, and so your ability to circumvent these indeterminate forms is going to be limited by your ability to recognize when to use various algebra tricks. And we'll work a ton of examples so you get more practice with that.